Okay, so question number one. The kinetic energy of a rigid body is a scalar product equal to half mv squared. In other words, kinetic energy Ek is also going to be half mv squared. What units is it measured in? Half is a half, it's a constant, you don't worry about it. Mass is kilograms, velocity is meters per second, and it's squared, so you put squared. In other words, kilograms meters squared over second squared. Or if you want kilograms meters squared, second to the power of minus 2. Because 1 over second is second to the minus 1, and if you square it, you square it, And yeah. Question 2. A body has a mass of 3, it undergoes velocity of 12. What is its kinetic energy? Kinetic energy is half mv squared. So half multiplied by 3 multiplied by 12 squared, which is 216 kilograms meters squared over second squared. Yeah.
So, question 3. In 1D, the work done on a body A is defined as the scalar product of the force acting by the displacement parallel to the, I'm guessing, axis of motion. I'm guessing, In other words, 1D work is equal to force multiplied by displacement multiplied by the axis of motion, and how you would do that is you would give cosine theta. Yeah? Work is therefore a measure of energy transfer. Nice. Energy transfer. I believe so. I asked Google to be honest. And it's measured in joules. J.
So question 4, a body of mass 3 is under the influence of a 20 Newton force to the east. It undergoes a displacement of 4. What is the work done? Previous question, we saw that work is equal to force cosine theta multiplied by displacement. Or in other words, f d cosine theta. Cosine theta. Now, in the question, they say that they're going in the same direction. Same direction, yani the angle between them is 0. If something is traveling in the same direction, they would be along the same line. If they had different directions, they would have different lines of action. So your force could be this, your displacement could be this, you know what I mean? So same direction, angle is 0. Cosine of 0 is 1. Displacement is 4. Force is 20. 20 times 4 is 80. And your work is 80. Unit of measurement is joules because it's work. Yeah. Okay, so question 5, the theorem of kinetic energy states that the total work on a body over displacement is equal to the change in its kinetic energy. That's the third blank. In other words, F delta x, force by displacement, which is your work, you know, is equal to, now force by displacement here, they mean force multiplied by cosine theta multiplied by displacement. Displacement is a vector quantity, so they don't need to put cosine here, okay? This is called the dot product. You don't need to worry about it, okay? If you have two forces, F dot V, this is the same thing as saying F multiplied by V multiplied by cosine theta, yeah? Because your force is a vector and your displacement is a vector. المهم, you don't have to worry about this. F multiplied by delta x is the same thing as saying F cosine theta delta x. It's equal to the change in kinetic energy. Change in kinetic energy يعني half mv squared final minus half mv squared initial, right? And yeah, that's the whole theorem. You can rewrite this entire thing as work is equal to delta kinetic energy. Delta يعني change. This means change, yeah. That's it. And boom, we're done. Okay, so question number 6. A body of mass 5 under the influence of a force 20 newtons, west 30 south. Yani, you have your west, you have your south, and you go from west to south by 30 degrees. And your force is 20 newtons. Cool? Get that out of the way. Its displacement is 6 along the same direction, yani in this direction. In other words, it's going to be minus 6 because it's the negative x-axis, صح? So minus 6. And your angle is going to be this entire angle, yeah? So 180 plus 30. This is 180 and this is 30. So in total, your angle, theta, is 210, yeah, 180 plus 30. Previous question, and they gave you the initial velocity, they're asking for the final velocity. Previous question, we saw that force by displacement by cosine theta is equivalent to half m v final squared minus v initial squared. Yeah, your force is gonna be 20 newtons. Your displacement is minus 6 because it's going in the opposite direction. Your theta is 210, as we said, and that whole thing is equal to half m, which is 5, v final squared, we don't know it. V initial squared is going to be 4 squared, which is 16. Now we simply have to solve, and we're going to get something. And that something is going to be, we shall see. We shall see. I got 7.58 or 7.56. That should be your answer. And it's your velocity, so meters per second, yeah? Oops.
So in question 7, which of the following cases does not cause a change in kinetic energy? Change in kinetic energy, as I said before, is this. V final squared minus V initial squared into half m. And this is of course equal to force displacement cosine theta. Which of the following causes a change in all of this, yeah? A boy pushes a wall with a force of 150, the wall doesn't move, yeah? Wall doesn't move, yeah, and displacement is 0. If this is 0, this entire thing is 0. Yani change in kinetic energy is equal to 0. So there's no change. So 1 is not true. Number 2, a particle of mass m falls under gravity. Yani if you have a ball over here, it falls and it reaches here. Yani there's a displacement, whatever that displacement is, 5 meters, for example, yeah? So that means your displacement would be 5. That means there is a change in kinetic energy because there's a displacement. Number 3, a body under the influence of a centripetal force and it executes uniform circular motion. In uniform circular motion, your velocity is constant and it's equal to 2 pi r over t. If it's constant, that means your v final is always equal to your v initial, yeah? So this is going to be 0, thus there's no change, you know?
Okay, so question number 8. So you can read the question, and the idea is, we said before that if you have an object, then the work is simply the change in kinetic energy, right? But the thing is, this only works when you're on a flat surface, yeah? If you're at an incline, you have to use something else. Because when you're at an incline, you actually have height, yeah? You're above something. You have height, yeah? Height h. And when you have height h, you have something called potential energy, which is mgh. Okay? So if an object is here, it has potential energy simply because it's at a height. Okay? At a distance above the surface, yani. Okay? And now if I let this object fall, yani this energy is constant and it's called u. Now if I let this object would fall till the very end. It will reach here, yeah? So that energy that you have, which is mgh, will be converted to motion. Motion. What is motion? Motion is kinetic energy, which is half mv squared. So here at the last point here, your potential energy will be 0 because you're at the floor. That means your height is 0. So your potential is 0. But you will have kinetic energy because you're moving. Kinetic energy is half mv squared. So at the top you had mgh and at the bottom you had half mv squared. Your mgh here is 0 and your half mv squared here is 0 because you're not moving at the top. Yeah? So in other words, your nice. Your potential energy was transformed into kinetic energy. And this is called the conservation of energy, yeah? It's by the principle of conservation of energy. Now let's read the question. A skier of weight 800 slides down a smooth surface at an incline of 30. Find the total work done by the normal push. Now, what is work equal to? In general, work is just force, distance, multiplied by cosine theta, right? They said normal push. Normal push, yani, they're talking about the normal. Yeah, your normal would look like this in our case because you're at an incline. Yeah. Now, since it's a normal force, the angle is 90 degrees. So theta is 90. يعني هاي 90. Cosine of 90 is 0. يعني your entire work is 0. Any work done by a normal force will always be 0, or a perpendicular force, you know? Let's read B. The total work done by gravity. هلا. So, okay. You were at this point. You had mgh. You weren't moving. So you had mgh, but your half mv squared was 0. Here you're at this point, your mgh now is 0 because your height is non-existent. You're at the ground floor, but you are moving. So you have mv squared. عم تتزحلقي من هون لهون يعني. You know? Okay. هلا the total work done is half mv squared or mgh because they're going to be equal. Mgh is going to be equal to half mv squared, yeah? Because this was transformed into this. Hence, this is equal to this, you know? So your work is just going to be mgh or half mv squared, but we don't have v, so we can simply just use this formula instead, yeah? So mgh, your mass. What the hell was that? What the actual hell was that? Anyways, your mass is not given, but your weight is given. mg يعني weight, 800, multiplied by the height. Now we need to find the height. So the angle of incline is 30 degrees, you know? So we're trying to find this height, not the distance you traveled, but the height itself, this height, which is simply going to be sine 30 multiplied by this distance, whatever this distance is. Yeah, this is point, let's say this is point B and this is point A. Yeah, so sine 30 multiplied by the hypotenuse. Actually, let me do it in white. This is the hypotenuse. Yeah, this is a right angle triangle. We're trying to find this height. So sine 30 multiplied by this to get this. So what's this? What's AB? AB is 100. So your height is sine 30 multiplied by 100. So your h is sine 30 multiplied by 100. So your mgh is 800 multiplied by this. So mgh is going to be 800, which is mg, multiplied by your height, which is sine 30 multiplied by 100. Now use a calculator and find that. You know, I'm just gonna do that. And we're gonna get 40,000. 40,000 joules, yeah? Now let's go to part C. What's the velocity? So we said that mgh is equal to half mv squared. Yeah. Now we found mgh and it's 40,000. So let's substitute 40,000. We have your mass. We have the mass. So the weight is 800. Yani the mass is 80. You know. And now just solve for v squared. Let's divide here and here. Yeah. So wait, 40,000 and this is 40. So simply 1,000 here. So yani your velocity is equal to what's the square root of 1,000? Let's see. 31.6 more or less, I believe, you know. So yeah, that's it.
Okay, so question 9. What does the effect of quadrupling a mass do on the kinetic energy? Your kinetic energy is half mv squared. If you quadruple the mass and you multiply by 4, what happens to the kinetic energy? So your kinetic energy is half mv squared. Factor out the 4. So this is your kinetic energy, Ke, right? So it's going to be 4 Ke. That means if you quadruple the mass, you quadruple the entire kinetic energy. Now in the exam, they're going to trick you and they're going to say, oh, well, it's going to be multiplied by 2 because you have half mv squared and you multiply it by 4. 4 over 2 is going to be 2. So you're left with this. But here's the thing. This is not kinetic energy. This is kinetic energy, you know? So you have to be careful. It's multiplied by 4, then you quadruple it. You don't multiply by 2. Okay, so question 10. A package of mass 8 is pushed along a horizontal floor, smooth horizontal floor, يعني ما في friction, by a horizontal force 16 newtons. It has a speed of 3 at A and the speed of 5 at B. Find the distance AB. So you have a floor, A, B. You have a box at A, it's being pushed by a horizontal force F, and its velocity at A is 3, its velocity at B is 5, find the distance. Now, since it's on a smooth horizontal floor, and it's not inclined, you can use the f d cosine theta is equal to half m into v squared final minus v squared initial. This is given to be 5 and you square it. This is given to be 3 and you square it. This mass is given to be 8 and you have a half. And this is equal to cosine theta. So wait, force is equal to 16 newtons. D, you don't know D, you want to find it. Cosine theta, they said the force is horizontal. The force is horizontal, and your floor is horizontal, and you're moving on the floor. So the direction of motion and the force are the same. So the angle between them is 0. Theta is 0, cosine of 0 is 1. So now you solve for D, and you get D is equal to 4. Now this whole thing, FD cosine theta is equal to half m v final squared minus v initial squared, is called the work kinetic energy theorem. And it only works when you're moving on a horizontal floor. If you have an inclined floor, that's a different thing. You have to use the conservation of energy, which is change in potential plus change in kinetic energy. And this is equal to work, you know? So yeah, this is a different formula. We're gonna go through it. We went through it in question 8, you know, but we'll go through it later in like question 15, I think. Okay, question 11. A body of mass 90 moves on a frictionless table with a uniform circular motion of radius 30 of velocity 15. Find the net force on the body. So you have a table, you have a ball on the table, and it's moving in a circle, yeah? So here's the table, here's the ball, and it's moving in a circle, yeah? And it's moving in UCM. Now, in UCM, your force is called your centripetal force. And your centripetal force is always equal to, which is this force, yeah? If you're moving in a circle, there's always a force pulling you towards the center. Hence the name centripetal. Centri, coming from the word center. Petal. Centripetal force, yeah? Your centripetal force, Fc, is always equal to mv squared over r, and it's the force pulling you towards the center. Mass is given to be 90, your v is 15, and you square it, over r, which is 30, and you should get 675. And since it's a force, it's in newtons. So question 12, a body of that mass is moving on a frictionless table of uniform circular motion of radius 60 and its speed is 55. The work done to the nearest joule. Now, in previous questions, we said that if you're on a horizontal surface, your work is the change in your kinetic energy. That is if you're on a horizontal surface. If you're not on a horizontal surface, if you're like on an incline, then it's different. You know, it's going to be your potential energy plus your kinetic, the change in your potential energy plus the change in your kinetic energy. Yeah. And we did that in a previous question somewhere. Okay. So now that you're on a horizontal surface, which is the table, your work is going to be a change in kinetic energy. Now in UCM, and kinetic energy is half m into v final squared minus v initial squared. Your change in kinetic energy, that is. In UCM, your velocity never changes. Your velocity is always constant. Your period is constant, your radius is constant, thus your velocity is constant. Yeah? So this velocity is equal to this velocity. They cancel out and they become 0. If this is 0, this entire thing is 0, thus your work is equal to 0. So in UCM, work is never done. Never, you know? Okay, so question 13, a force displacement graph is given. Determine the amount of work done between 0 and 5 meters. Okay, now, the relationship between work and the force displacement graph, the work is always the area under the curve. Yeah, this whole area, the area under your function, whatever it is, this weird shape they gave you. The area under it is your displacement. Okay, in other words, and what is an integral? An integral means area under curve. Under curve. Yeah? So your work is going to be equal to the integral of your force, which is the y-axis, multiplied by d of your x-axis, whatever your x is. Yeah, your displacement in our case. Yeah? This means area under the force displacement axis. Okay? You don't really need to know the integral yet. You'll take it next year. All you have to know now is work is equal to area under graph of F versus displacement. Force versus displacement. So if you look at your graph, they want this whole area from here to here. Yeah. Now, if you notice, this triangle is equal to this triangle. Yeah. The difference is this triangle is under the x-axis. This triangle is under the y. Is above the x-axis. So this is negative and this is positive. So they cancel out. So the only area you're actually left with. Okay. Please erase. Please, I said. Okay. So this is the area you're actually left with. This whole weird shape, yeah? Let's break it down. You have a rectangle over here. It has a height of 2. So it has a height of 2 and a base of 3. So 3 multiplied by 2 plus this triangle, which has a base of 2 minus 1, which is 1, and a height of 6 minus 2, this whole distance, which is 4. So the area is going to be half 1 into 4 plus the area of this rectangle, the one left out. This is going to be 1 and this height is going to be 6 minus 2, which is 4. So 4 multiplied by 1. If you do that, that's 4 plus this is a 2 plus a 6. So this is a 12. And since you're finding work, so it's 12 joules, you know?
Okay, so question 15. A body of mass 18 moves on a horizontal and it's a rough surface, يعني في friction. The body is subjected to a force. So here's the body, call it a point. It's subjected to a force of 60 newtons, making an angle 30 with the horizon. That's 60 newtons. So you have let's put the axes. Okay, let's put the axes. Fuel. Okay. Making an angle of 30. Of course, you have your friction because, rough surface. They told you coefficient of friction is 0.3 and the distance moved is 140. Find the work done. Okay, so work is equal to force multiplied by distance multiplied by cosine theta, right? Well, here we go. So what are your forces acting on the F cosine theta? Yani the forces acting on the horizontal, yeah? Here the angle is 0. The friction is making an angle 0. Cosine 0 is 1, yeah? And here you need to find the component on the x-axis, which is this one. Call it capital F1, which is just going to be 60 cosine 30. صح? So now we have our forces. F cosine theta is simply this and this, you know? So let's do it. So yani you have your distance outside and then you have 60 cosine 30. And of course friction is in the opposite direction, it's negative. And your distance is 140. So all we have to do now is find friction. Once we find friction, we just substitute it. Hello, what's friction equal to? Mu multiplied by the normal. What's mu? Mu is 0.3. What's the normal force now? Now here, if you look, you have your normal force, you have your weight, and then you have this force over here, which is 60 sine 30. Any n plus 60 sine 30 should be equal to the weight, صح? So in other words, your normal is your weight minus 60 sine 30. Let's do that. What's your weight? Your weight is 180 because your mass is 18 minus 60 sine 30, and that's going to give you 150. Yani your normal force is 150. Okay, cool. Your normal is 150. In other words, your friction is 45. So let's input it. So your work is going to be 140 into 60 cosine 30 minus 45. If you solve this, you get 976 or something, yeah? Okay, 974.6. In the paper, they got 1008. I don't really know how. I think because they rounded, but we did the same steps. We did the exact same steps. Maybe it's because I put cosine 30 and they put 0.87, So, yeah.